A rare visitor from deep space is in fact racing through our solar system, and it's breaking records on the way. Scientists have confirmed that the third ever interstellar object, named 3I Atlas.
The comet is on an extremely unusual path, moving too fast to be bound by the sun's gravity.
A brand new interstellar object has just been spotted, and it's racing through our solar system at a record-breaking speed. Named 3I Atlas, this cosmic intruder was first detected on July 1, 2025 by the Atlas Survey Telescope in Chile. Unlike anything bound to our sun, its hyperbolic trajectory proves it came from deep space, traveling at a mind-blowing 130,000 miles per hour, 210,000 kilometers per hour. Astronomers worldwide scrambled to track it. The Hubble Space Telescope captured stunning images on July 21, revealing a fuzzy coma and teardrop-shaped dust cloud surrounding a solid icy core. At an estimated 10 kilometers wide, it dwarfs Oumuamua and rivals Comet Borisov. Even more shocking, 3I Atlas started spewing water vapor and forming a glowing tail while still far from the sun, a rare behavior for comets. This mysterious traveler is already rewriting what we thought we knew about interstellar visitors. Scientists were stunned when 3I Atlas showed signs of water and icy grains, proof it's packed with volatile material. This hints it may have been born in the Milky Way's thick disk, a region known for ancient, water-rich objects. Its motion confirms it's drifting upward through the galactic plane, with an estimated age of 3 to 14 billion years, possibly older than our entire solar system. But then came the wild speculation. Harvard's Avi Loeb pointed out its bright glow, massive size, unusual chemistry, and eerie orbital alignment, even suggesting it might be an alien probe. That theory went viral, though most astronomers insist its comet-like outgassing proves it's natural. What's certain is that Earth is safe. At closest approach, it'll stay 1.8 astronomical units away, farther than Mars. Still, when it swings near the Sun in late October 2025, telescopes worldwide will lock in, eager to capture every secret before this ancient traveler vanishes back into deep space. When Comet Borisov passed through in 2019, it looked like a textbook comet. Familiar, almost ordinary. But 3I Atlas is a whole different beast. Its insane speed, extreme orbit, and ancient age blow past every model scientists thought they understood. This isn't some stray rock nudged into our solar system. It's a true runaway from the galaxy itself, untouchable by gravity and impossible to trap. Its retrograde, tilted orbit, and likely thick disk origin suggest interstellar visitors can come from directions astronomers once dismissed, forcing new strategies for future sky surveys. And its makeup, water ice, organics, and dust grains, could hold the same ingredients that once built planets. By studying its activity far from the Sun, scientists can test how comets behave under cold, distant conditions, revealing clues about dust, tails, and nucleus structure. With James Webb and Hubble locked in, every image, spectrum, and light curve adds another piece to the puzzle, showing us how alien star systems fling debris across the galaxy and straight into our backyard. From the start, 3I Atlas appeared brighter than expected, a hint it might be flaring, breaking apart, or hiding explosive outbursts inside. Whatever happens, each twist reveals secrets about its inner structure after billions of years drifting through interstellar space. Astronomers know this is just the beginning. With new survey telescopes coming online, dozens of interstellar objects could soon be discovered every year. Each one builds the sample, showing us what kinds of travelers the galaxy sends our way, and how they shaped planet formation across the stars. As 3I Atlas races through its one-time visit, telescopes worldwide are locked in. Observations showed it rotates every 16 hours, with tiny brightness shifts hinting at rough terrain and uneven surfaces. Over the weeks, its coma even shifted toward a deepening red glow. signs of fresh dust or irradiated organics being exposed. This mysterious wanderer isn't just passing by, it's evolving right before our eyes, leaving behind clues that could rewrite how we understand cosmic visitors. One of the biggest shocks came when Swift Observatory spotted faint water vapor emissions from over 3 astronomical units away, far beyond the range where comets in our system usually release water. That glow suggested an active surface of nearly 19 square kilometers, remarkable for a body whose true size is still being refined. 2 rival theories emerged. Some scientists say icy grains in the coma, not the nucleus itself, explain the early water release. Others argue radiation may have baked a crust of organics, delaying outgassing until deeper layers warmed. And then there's its trajectory, almost perfectly retrograde, just 5 degrees off the ecliptic. For most, it's pure orbital mechanics. But for Avi Loeb, the precision feels almost intentional. Even as speculation swirled, data kept pointing toward a natural comet, dust reddening, distant water emissions, and steady rotation. Size estimates shrank too, from 20 kilometers down to 3 to 6 kilometers across, still making 3IATLAS one of the largest interstellar wanderers ever caught in our view. The latest images of 3IATLAS showed its glowing coma swelling day by day, tracked with incredible precision. Archival surveys even revealed it was active as early as May 2025 at a staggering 6.4 astronomical units from the Sun, way too far for a typical comet to wake up. That early activity only deepened the mystery. By late summer, its brightness crept up, faint but visible at magnitude 14 to 16, enough for long-exposure astrophotographers to capture its ghostly streak across the stars. Come October, it promised its brightest display, before slipping into solar conjunction, disappearing in the sun's glare, then re-emerging weeks later. Even more jaw-dropping is its origin story. Calculations trace it back to the Milky Way's thick disk, making it possibly 7.6 to 14 billion years old, older than our Sun itself. That means we're looking at a relic from the galaxy's earliest days, built under conditions wildly different from today. This single object forces astronomers to ask, is it part of a hidden class of ancient icy survivors? And how many more like it are still roaming unseen through the dark? The arrival of 3IATLAS is rewriting more than comet science. It's testing how we understand planet formation, thermodynamics, and survival across the galaxy. Its odd behavior, from early water vapor to its rapid 16-hour spin, gives scientists a chance to push models of small-body physics further than ever before. What's just as striking is the teamwork. From Hubble to James Webb, from Rubin to TESS, observatories across Earth and space are watching in sync, a level of coordination that would have been unthinkable just a decade ago. And this is only the beginning. Astronomers expect future surveys to uncover dozens of interstellar objects each year. As 3IATLAS swings near the Sun at 1.36 astronomical units on October 29, 2025, Mars orbiters may catch it in passing, with Jovian missions lining up in 2026. Every dataset, every spectrum, every frame adds to the story of how alien matter responds to sunlight, gravity, and deep space radiation. For humanity, this fleeting visitor is a reminder. We're just beginners on a young planet, glimpsing relics that predate our Sun, ancient travelers whispering across light years into our sky. From the start, spectroscopy peeled back the layers of 3IATLAS, and what it revealed shocked astronomers. The SOAR telescope in Chile detected a faint red spectrum, like distant trans-Neptunian objects, with hints of complex carbon compounds and irradiated organics. Yet the usual comet gases, CN, C2, CO+, OI, were nowhere to be found, leaving scientists baffled. How was this thing active without the standard drivers? By July, global teams tracked its 16-hour spin, with subtle brightness shifts pointing to uneven terrain. Its coma reddened, dust thickened, and Hubble locked in on the inner coma, measuring dust loss at 6 to 60 kilograms per second, depending on grain size. That data hinted at a nucleus radius between 2.8 kilometers and 160 meters, wildly uncertain, but clearly no ordinary rock. Then came the breakthrough. Swift Observatory detected hydroxyl emissions, proof of water sublimation at nearly 40 kilograms per second. That means at least 19 square kilometers of surface was active, with possibly 20% of its body erupting water, far more than any comet in our solar system. Some of that water may even be streaming from icy grains in the coma itself. As scientists tracked 3IATLAS, they found its activity firing up far from the Sun, at distances where sunlight shouldn't have been strong enough. Japan's Subaru telescope added clarity, revealing the comet to be extremely red, like D-type asteroids rich in dark organics. Its brightness stayed steady, showing a smooth spin with no sudden outbursts. But then came speculation. Avi Loeb noticed its near-perfect alignment with the solar system's plane and proposed something radical. Could it be artificial? He floated scenarios of particle sprays acting like shielding, the kind of tech a spacecraft might deploy. On his own Loeb scale for alien plausibility, 3IATLAS scored a 4. Not proof, but enough to spark imaginations. He even suggested humanity might consider sending it a message after perihelion if its behavior turns out strange. Amid the buzz, real science pushes forward. With perihelion in late October and a December reappearance, agencies worldwide are racing to gather every scrap of data, from James Webb, Mars orbiters, and ground telescopes, before this mysterious traveler vanishes back into the dark. The orbit of 3IATLAS is unlike anything local. Tilted at 175 degrees, retrograde, and sweeping past Mars in October, skimming by Earth at a safe distance after perihelion, then drifting near Jupiter by March 2026. A cosmic dance across multiple worlds in a single arc. Tracing its galactic orbit places it in the Milky Way's thick disk, making it possibly older than the solar system itself. If true, its chemistry is a fossil record from the galaxy's youth, somehow surviving radiation, collisions, and eons of interstellar drift. Every detail, its dust emission, surface activity, strange coloring, is like a whisper from another era. High-resolution imaging from the Lowell Discovery Telescope even revealed its tail twisting with subtle asymmetry, likely from localized vents blasting jets of vapor and dust. This uneven outgassing mirrors the behavior of long-period comets from our own Oort cloud, except this traveler began its journey light years away. And thanks to Hubble, Swift, SOAR, Subaru, Rubin, and soon Webb, this isn't just a fleeting glimpse. It's a full-scale investigation of a relic from deep time. Unlike any comet we've seen, 3IATLAS is a true alien relic, shaped in a distant star system, venting patterns sculpted by forces unknown. European polarimetric studies revealed its dust grains scatter light with higher polarization than typical comets, hinting they're far more pristine, untouched by endless orbits around a parent star. That means we may be looking at unaltered dust from billions of years ago, a time capsule from deep space itself. Thermal models suggest its ices activate at surprisingly low temperatures, explaining why water vapor appeared so early and so far from the sun. Scientists suspect exotic ice phases, even amorphous water ice-trapping gases, may be buried inside, ready to burst free in explosive jets. Infrared readings from Mauna Kea added fuel to the mystery. The surface looks dark and organic-rich, a layer that could insulate the nucleus until pressure forces violent breakouts. Meanwhile, orbital studies suggest this traveler may have even crossed a dense molecular cloud long ago, carrying scars and secrets from deep galactic history. Every fresh glimpse of 3IATLAS reveals new surprises. If isotopic anomalies in its hydrogen or oxygen ratios are detected, they could confirm an exotic birthplace in a star-forming region unlike anything near our Sun. The collaboration surrounding this comet is massive. Amateurs with long-exposure images are feeding data into professional models, catching tiny surges of brightness that hint at local outbursts. Even the faint ion tail, teased out in stacked telescope images, tells a story. How this alien body reacts to the solar wind for the very first time. By September, a delicate shift in its halo revealed something rare: sodium emission lines detected by the Grand Canary telescope. This suggested alkali-rich minerals being released as the nucleus cracked under thermal stress, exposing material untouched since another star system birthed it. In just a short window, 3IATLAS has become a cosmic laboratory in motion, testing our instruments, pushing our theories, and showing us mineral signatures and volatile behaviors we've never seen in any comet before. Ultraviolet follow-ups with Hubble revealed a subtle glow pattern in 3IATLAS's coma, denser on the sunward side, hinting its tilted rotation may be creating seasonal effects. If true, this would be the first time seasonal changes are documented on an interstellar body. At the same time, ALMA detected faint traces of simple organics like formaldehyde or methanol, molecules that could link this alien comet to the same prebiotic chemistry that seeds habitable worlds. Imagine frozen building blocks of life, preserved for billions of years in deep space, now drifting through our skies. Dynamic simulations also suggest that solar radiation pressure is nudging its smallest dust grains, a shift that helps reveal their size and density, details that can reconstruct the very texture of matter born in another star system. This is more than a comet. It's a message from the galaxy's past, and we're just beginning to decode it. Don't forget to like, share, comment, and subscribe for more cosmic discoveries.